The last one, example 4, we actually talked about a little bit last time. We said we have this complicated problem and we need to either have it in tangents or secants, but not both. The best way to do that is to use a Pythagorean identity, but it has to be squared in order to use a Pythagorean identity. So therefore we're going to square both sides. That also has an advantage of getting rid of that square root. But then we also talked about this last time, that if we square both sides, we must check our answers at the end, because when you start a problem by squaring both sides, you mess things up a bit, so there's usually an extraneous solution when you're finished. Okay, so square both sides first. Let's see if I can write and record at the same time. Otherwise, so we end up with tangent 3y times tangent 3y is, of course, tangent squared 3y. And then we have 1 times tangent 3y plus 1 times tangent 3y gives us 2 tangent 3y, and then 1 times 1 is 1. And then on the other side of the problem, we have the square root of 2 times the square root of 2, which is 2. And then we have secant 3y times secant 3y, which is secant squared 3y. Next thing we're going to do is take that secant squared 3y and replace it with the Pythagorean identity, which is tangent plus 1. So we're going to just take that whole thing and replace it with tangent squared 3y plus 1. And of course that whole thing is times 2. So then we will have 2 tangent squared 3y plus 2. Okay, so the other side of the problem is still the same. Now we just want our quadratic to be equal to 0. So we're going to take everything on this side and combine it over here with everything on this side. So the result of that is a negative tangent squared 3y plus 2 tangent 3y plus 1. So that came equals 0. That came from moving this stuff, subtracting it over from this stuff over here. Okay, now I prefer to work with problems that don't have this negative out in front. So I'm going to go ahead and change everything that's negative to a positive and everything that's positive to a negative. So that gives me tangent 3y minus 2 tangent 3y minus 1 equals 0. And now this is a quadratic that's factorable. If you need to, go ahead and use a substitution, a u substitution, and your u value would be tangent 3y. So this would be u squared minus 2u minus 1. I'm not going to do it that way, but you could. So I'm just going to go ahead and factor it as is. It'll be tangent 3y minus 1 binomial squared, because this is a perfect square trinomial, isn't it? Okay, so we are subtracting this 2y, or this 2 from both sides. So we can take the 1 minus the 2, gives us actually a negative 1 here, which makes this one a positive 1, which makes this a perfect square trinomial, and therefore it becomes a binomial squared. Okay, so since that's a repeated factor, we only have to solve it once. So we just take our tangent 3y minus 1 equals 0. We're just setting our factors equal to 0. They're both the same, so we're going to get the same result, so we don't need to do it twice. So tangent of 3y equals 1. So 3y would equal where the tangent is 1, so that happens at 45 degrees in quadrant 1 plus 180. Okay, because tangent repeats every 180. So quadrant 1 and then quadrant 3. But that's 3y, so then we have to take both sides and divide everything by 3. So y equals 15 degrees plus 60k. So now we could just go through and find all of the answers that would be between 0 and 360. So the first one would be 15, and then we add 60 to that, and we get 75, and the next one would be add 60 to that, so 135, and the next one would be add 60 to that, so 195, and the next one would be add 360 or 60 to that, so that would be 255, And then the last one without going over 360 would be 305. Then I showed you this last time. You must check your answers. And so it ends up that when you actually plug your answers into the original problem, like you plug in 15 degrees. 3 times 15 is 45. Tangent of 45 is 1 plus 1 is 2. And then secant of 3 times 15 would be the secant of 45, which I believe is 1 over square, no, 2 over 2, no, I don't remember what it is. Anyway, you multiply times the square root of 2, we did this last time, and you should get 2 over here. So the 15 actually does work, but then if you try plugging in the 75, you will not get the same answer on both sides. So that one doesn't work. It ends up that we probably should have, well, tried 15 and then tried, I'm confusing myself. This is a horrible video. Anyway, basically the ones in the third quadrant from the original problem, third quadrant, doesn't end up working. So it's just the first quadrant answers plus the 60, or plus the 120, because it would be all the way around the circle and then divided by 3. That works. Complicated, and I probably haven't made it sound any easier. So I hope you can manage this. Good luck. See you soon. Bye.